Hello friends, welcome to the Programming Hub. Today, this is actually a problem solving session on prime number. So our agenda will be writing the program for finding the prime number, how to find the prime number. And first we will be writing the brute force, and second we will try to optimize that how much we can. And second program we are going to see print all the prime number from 1 to n, and same thing we are going to do with second program also. So in order to finding like what is optimum solution, we are going to compare the tc. You know what is tc? This is time complexity. Time complexity. So basically, when we will write the brute force, we will try to find what is the time complexity for that program, and same thing when we will optimize that, then we will try to find the time complexity, and then we will compare how we can say this is a brute force, and second or third, whatever may be the number, how that is optimum solution. So first we will talk about what is prime number. So we should know, if we are writing the program for anything, then we should know what is that concept actually. So first thing, what is prime number? So basic definition, if we are going to say about prime number, then we can say the number which is which can be which can be divided by 1 and itself. Okay, 1 in itself. So what I'm trying to convey is, so let's say I'm taking any number. Let's say I'm taking 10. So it can be divided by 1, it can be divided by 2, it can be divided by 5, and it can be divided by 4. So you can see the prime number definition is the number which can be divided only by 1 and itself. So let's say I'm taking 11. So you can divide 11 by 1 and 11. Let's say I'm taking 13. So you can divide 13 only by 1 and 13. Let's say I'm taking 15. You can divide 15 by 1, 3, 5, and then directly on 15. So you mean to say that if you can say 11 can be divided only by 1 and 11, it means that this is a prime number. We can say 11 is a prime number, and 13 also can be called as a prime number. And if you are going to talk about 10, it is not prime. It is not prime, and same way you can say this 15 is also not a prime number. Now, so if you will see this, so this is nothing. This is factor of 10. So you can say what is factor? Factor meaning is the number, if number can be divided by any other number, so that other number will be factor of this. So 10 can be divided by 2, meaning that 2 is a factor of 10. If 10 is divided by 5, 5 is a factor of 10. Let's say I'm going to talk about 15. 1 can be, 15 can be divided by 1, meaning that 1 is a factor of 15. So 3 is also factor of 15, 5 is also factor of 15, and 15 is also factor of 15. So if in terms of factor, if we are going to talk about prime number, we can say if any number is having only two factor, then that is a prime number. Can we say or not? Yes, we can. So if any number is having only two factor will be called as prime number. So we already discussed. So what is this and all? This is a factor of 10. This is a factor of 11. This is a factor of 13. This is a factor of 15. So if any number is having only two factor, meaning that we can say that is a prime number. So what we are going to write, if we are going to approach any problem, either it can be any problem, okay, you have to observe the things. If you are observing correctly, meaning that you will be able to write the program in right way. Okay, so what I have to do, if anyone is giving me number, let's say they are giving me 10, so what I have to do in brute force, I have to divide till 10. If it is divided by, if it is having only two factor, then we can say that is a prime. If count is more than 2 of factor, then we can say that is not a prime. As simple as that. Okay, let me write the program for, let me write the pseudocode for that, then you will get more clear. So let me, let's say I'm writing boolean check prime. Okay, and I will be given one number. Okay, so what first thing what I have to do, I have to take one count, because I am going to count the factor. So I am going to take count. Okay, don't worry. We are going to write the program also in Notepad and all. In Notepad or Eclipse, we will run also. This is just a pseudo code. Don't see the syntax and all. What is the syntax and all? Pseudo code, it is like just we are means some kind of giving step by step how we are going to solve the problem. Okay, this can be written in any language. It can be written in Python, or it can be written in C, or it can be written in Java as well. So at the end, I will be writing in Java, and you people can try in any of the language as in which you are very much comfortable. So I'm writing check prime. I will be given as a one number, and then I'm going to count the factor. So for counting the factor, what I have to do, I have to start the loop from 1 and 2, that number, and that number I have to divide with each and every number. If it is getting divided, I will increase my count, and at last I will be writing the means making one condition kind of, and if the factor count will be only 1, then we can say that number is only 2, sorry, or 2, then we can say that is that number is prime. Okay, so let's say for int I equals to 1, and then I should go till n and I plus plus. Okay, so what I have to do, if number modulo division I equals to 0, then we can say count plus plus. So initially what will be the count? Initially count will be 0, so let me put the 0 as well here. So it will be 0, and then we can end the loop. Okay, fine. Now I will be having what is the number of factor. So what I can do here, if count equals to exactly 2, then we can say return true, meaning that number is prime. If it is more than or something, then we can say return false. Okay, then we have closed the, let's say I'm taking, we have closed the if, we have closed the for loop, we have closed the if, we have closed the else, and then I have to close the function as well. Okay, so this is my normal program for printing the checking the number is prime or not. Okay, so now we are going to talk about the time complexity. So time complexity, if you are finding, so we are going to run this loop for n number of time. Okay, and this is a constant operation. It, for if number is 50 also, this will take same time, and if it is number is 100 or more than 1000 also, this operation will take constant time, and this operation will be depending on the value of n. So we can say in big O notation, we can say the time complexity for this program will be O of n. And space complexity, we are not taking any extra space. So this is int, this will be normal constant only. We are not taking any, we are not creating any new things here which will take n time. So we can say sc will be 1, O of 1. So this is the our time complexity, and we can say this is our idea 1. Okay, this is idea 1. Okay, so let's say, you can see we are running now. It is, let's say I'm checking whether 50 is prime or not, and this loop will run for 50 number of time. Okay, if this loop, this n is having value 100, so it will run for 100 number of times. So automatically, whenever the number value is getting increased, automatically your O of n also will be increasing, time also will be increasing. So somehow, if we are going to minimize the solution in something else also, then less than n linear time, then that will be very good solution. Okay, so let us discuss idea 2 now. Idea 2. In this idea, in previous things, what we have seen here, we have seen like we are counting the factor. Okay, and whenever the number is prime, then only it will be two factor. So just I am supposing now, I'm sorry for that. Okay, just I will take one constant kind of, let's say let's say I and j is factor of n. Okay, meaning that if there is two factor, so basically what I'm trying to say, if I and j are factor of this number, where is my pointer? Okay, so we can say I and j equals to n by I, meaning that if I is a factor of n, automatically n by I also will be factor of n. Agree or not agree? Okay, not agree, no problem. Then we will take one value. Let's say I'm taking 20, and here I'm writing I, and I'm writing n by I. Okay, so let's say I'm taking 1 first value, n by what will be n by I? 20 by 1. So this value will be 20. So 1 is factor of 20, and 20 is also factor of 20. Correct? Let's say I'm taking 2. So automatically we can say 20 by 2 is also factor, means 10. We can say 10. So instead of writing 20, instead of 20 by 1, instead of writing 20 by 2, here in this place I can write 20, and in this place I can write 10. So you can say if I is a factor of n, the automatically n by I also will be factor of n. Let's say 3. 3 is not a factor of 20, correct? So 3, I'm not going to write. 4 is a factor of 20. Yes, 4 is factor of uh, 20. So 20 by 4 will be 5. 5 will be factor of n. Same way, let's say I'm writing 5. Then 5, 20 by 5 is 4. So 4 is factor of 20. Same way, if I'm writing, I think 6 is not a factor of 20, 7 is not, 8 is not, 9 is also not, then 10. 10 is a factor of 20, so automatically 20 by 10 also will be factor of n. So same way, 15, 11, 12, 13, nothing is there. So directly I think 20 is a factor of 20, so automatically 1 will be factor of this one. Okay. So we can see, so if we are going to start our loop and finding the factor n by I factor, then automatically 1 is a factor, so 20 will be factor, 2 is a factor of 20, so 10 also will be factor, 4 is a factor, so automatically 5 will also will be factor, and then 10 is a factor, so automatically 2 will be factor, and 20 is a factor of 20, so automatically 1 will be the factor of 20. So you can see 1, 2, 1, 2, 4, and 10 and 20. And here if you will go from n by I value 1, 2, 5, 10 and 20. So what numbers and all is repeating? So numbers are repeating 1, 4, 2. So if you are saying, if we will take only till this part, if we are going to run only till 4, then we will be getting all our factors actually. No need to count on this actually, because here we are seeing numbers are repeating. So I mean to say that instead of running the loop till 20, if we are going to run till 4, automatically we will get the number. Correct? So what are the observation here we are getting here? Observation 1 is, we will say this one is a part 1 and this will be part 2. So we can say if only need part 1 to get all the factor, and then this is observation 1. Second observation is I should be less than n by I. Correct? So here same thing we are doing. I should be, so meaning that this 4 and now it became 5. So n by 5 is 5 here itself. So we have to run our loop till n by less than n by I. And if we are going to talk in different term, next term we can write I multiply by I should be less than n. So this is our observation number 2. So if we are going to run the loop till here itself, then we will get the our desired output. Am I correct? Any problem? Okay, let me take new page. So basically what we got from here, we are going to run the loop till this place only, till I into I, and then we will talk about the time complexity, how it is getting reduced. Okay, so let me write the code now. So we can talk like, once again, boolean check prime. Once again I will be having one number, and then what we can see, we can write the count, and then we can say for I should start from 1. I should into I should go less than n, and I plus plus. Okay. And now another thing, another observation you have to see here. Every time whenever I is some having some value, then I have to calculate 1 n by I also 2 times, meaning that every time if I is getting divisible uh, by n, then we have to increase the count by 2, not by 1 actually this time. Okay, so this time if n is modulo division I equals to 0, then we can write count equals to count plus 2, not 1. Okay, and then close the loop, and then we can say if count equals to 2, then return true, and we can say directly return false also. No need to, because if it is having only 2 count, then it will return from here itself. If it is not getting true, meaning directly we can say that number is not prime. Okay, any problem? So here you can see you have drastically changed the change your time complexity. So here if you see the value for time complexity, tc equals to O of I into I. So it is not running. So first time it is running for 1, 1 into 1, meaning that 1 is less than n. And what is n actually? 20, meaning that first time it is. Now for 2, 2 into 2, then it will be. So if you are going to talk about dry run, let's say I'm going to dry run for this. Okay. So first time it will be having I equals to 1, 1 into 1 less than equals to 20, meaning this is true, then it will divide. So we are not going to talk about this factor. Okay, this. So once again I will become 2, 2 into 2 less than 20, this is also true. What is prime and all we will check here. Okay, I'm just saying how many number of time loop is getting executed. Last time we saw if 20 is the number, 20 times loop will be executing. So here 3 into 3 less than 20, and I equals to 4, 4 into 4 equals less than 20, this is true. Then I equals to 5, 5 into 5 is less than 20 is wrong, meaning that 1, 2, 3, only 4 time loop is getting executed. So we can say roughly, not roughly, exactly it will run for square root of n. Okay, so you can see how many. If it number is 50, it will run only for 7 number of time, not more than that. So you can see how much time complexity now it is got reduced. Okay, so where is my pointer? Okay, SC is same, like we are not taking any extra space for this also. Okay, so till now we saw what is the time complexity, but in this program there is one edge case that you have to solve it out. Okay, what is the edge case we are going to talk? There is one edge case, we have to talk about that also. So last time we have taken value and as a 20. Let's say this time I will be taking n equals to 25. Okay, so what we are going to calculate? I is what? 1. So we are going to calculate n by I, so this will become 25, and then next thing what, it will be 25 will be divided by 5. So okay, this is a correct example, not a problem. Okay, no problem, we will take another example. So this is also 5, and next time this will be divided by 5 and 1. So you can see here, if we are going to talk about this part, this 5 is coming for twice. Another example, let's say I'm taking n equals to 36. So I and n by I. So this will be divided by 1. This will be 26, 36. Then this will be 2, and this will be 18. This will be 3, and this will be 12. This will be 6, and this also will be 6. Then this will become 12, and this will be 3, and this is 18. This will be 2, and then 36, and this will become 1. Okay, so we are going to talk only on the first part. Here also, if you see, then what is this? 6 is, we are counting twice. It is mean that 6 is getting counted. If number is perfectly square, then you are going to talk, we are you are going to increase your counter by 2 actually. So that should be 1. So you have to handle this case. Okay, so let me handle that case also in same program. So what is the edge case here? So just we have to, what we have to do here. Okay, I need some space. So let's say if I equals to n by I. Okay, if this is the case, then count plus plus. Okay, and then I need some more space. Okay, okay, no problem. I will write one more time. Else count equals to count plus 2. Now this will be perfect program now. Okay, any problem till now? I don't think so. So this is the at most we can do, I according to my logic. Maybe you are trying to find something else. Okay, happy to do that, happy for you, and you can try to optimize more. So but according to me, this will be not more optimized actually. So this was our first program actually. Let's go and talk about second program now. So we are going to take another page, and our second program is print all prime print all prime number from 1 to n. Okay, so what is the brute force? So first we always talk about the brute force. So if same program, but what we have to do, you have to make another loop, meaning that iterate from 1 to n and check whether I is, or you can say that I is prime or not. If it is prime, then you print, otherwise you skip. Okay, so if we are going to write the program for this also, so what will be the, So void print all prime. So 1 to n, meaning that I will be getting n. Okay. Now what I have to do? For I equals to 1, I less than equals to n, I plus plus, and here if already we written the checking the prime number, so we can call check prime, and you can pass I as a number, and if it is true then you can print I, else not print, and then close this also. Okay, so this is our if closing, this is our for closing, and this is our main function. Okay, I hope it is clear. This is nothing, this check prime is nothing above function. We just seen like how to check the prime. Okay, so if we are going to talk about time complexity for this also, so this check prime was taking square root of n, and now over the square root of n we have another loop which is running for n time. So for every number this loop will run for square root n, so we can say another n. So this will be your time complexity, and this is a huge time complexity, you can see. So n into, let's say, 50 and number 50. So for 1 this will run for the square root of time. If it is number is 40, so 7 time it will run. So you can think, so for every number this loop will run for square root of time. So this is a very huge time complexity. If we are going to talk about space complexity, we are not taking any extra space, so this will be still O of 1. Okay, let's say we will go now for idea 2. Idea 2. Okay, so for idea 2, let's say I'm taking number 50. I think 50 will be very big number, so let me take something like 30. Okay, so now listen carefully what how I'm going to approach, because this is nothing like you will get immediately. So I also learned somewhere, and how we are going to approach this. Let's say I'm writing all the numbers now: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 20, sorry, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, this is our all the number. So now I have to check which number is prime and all now. And if it is prime, then I have to print that out. Okay, so in beginning, so first step is, let's say all numbers are prime. Okay, so let's say I'm taking in this color and I'm going to highlight this this number is also prime, 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 this number is. So what I'm trying to do, this is prime, this is also 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 prime. Okay, this is also prime, prime. Okay, 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 okay. So all are prime. I'm considering all numbers are prime. So here I'm writing if this is marked with this color, then prime. I'll take another color now. Let's say I'm taking this color. Okay. And here I'll be writing not prime. Okay. So now what we are going to do, we will be starting with this value. And if that number is prime, then we will do some other operation as well. So first value is not prime. We know one is not prime. So we are going to discuss this at all. This. Okay. 2 is prime. This is first because one we are not going to talk about because one is divided by all the numbers actually. We can divide any number with one and one itself is not a prime. So we are not going to check about this at all. This is a edge case we will handle in our program itself. This is a edge case. Okay. Now if you see 2 and it is highlighted by green color means we can say this is a prime. Okay. So what we are going to do in the range of all the numbers, we are going to divide into other number. Let's say 2 means 2 into 2 we will divide. So this is 4 and we will mark this number is not prime. Same way 2 into 3 means this number is not prime, meaning that if any number is prime and from this number if other numbers are divisible, meaning that it is also not prime, because you know if any number is divided by some other number and which is not itself or 1 means that is not a prime, meaning that 4 is divided by 2 meaning 4 cannot be prime at all. If 6 is divided by 2 means we can say 6 is not a prime number. Okay. So with this 2, we can say 4 is divided. So we will mark this. This is not a prime. So we can mark this also. 6 is also not prime. 8 is also not prime. 10 is also not prime. Then 12 is also not prime. 14 is also not prime. 16 is also not prime. Like that 18, 20, 22, 24, 26, 28 and 30. Okay. Okay, fine, very good. Okay, so next step we will go further. If we are going further, 3 is a prime. Why? Because it is colored in green color. So 3 is prime. So now we are going to multiply 3 into 2. If that number also cannot be prime, because if that number is divided by 3, meaning that that cannot be prime at all. Okay, so we will mark again. So 6 is divided by 3. So this is not prime. 9 is divided by 9 is multiplied by 3. So 9 is multiplied by divided by 3 means 9 is also not prime. 12 is not prime. 15 is also not prime. 18 is also not prime. Then 21 is not prime. 24 is not prime. Then 27 is not prime. Then 30 is not prime. Fine. So till now we reached. First we checked for this, for next we checked for 3, then now we will check for 4. 4 we can see it is already not prime. If if it is not prime number. If it is not prime number, then we will not check. Okay, so this will be exception case. Once again we are not going to check for this. So from in loop what we are checking actually, if number is prime then only we will multiply by 2, multiply by 3, multiply by 4, and whatever the outcome, those numbers we will mark as a not prime actually. So 4 itself is not a prime. 4 itself is not a prime, so we will not check that. Now we will go for 5. So if you see 5, 5 is marked with green color. It means that this is a prime number. And now we are going to multiply by 2 and mark that number as a not prime. Okay. So 5, meaning that 10 is not a prime number, meaning that 15 is not a prime number, meaning that 20 is also not a prime number, 25 is also not a prime number, and 30 is also not a prime number. Okay. Okay, super. Now we will go for 6. 6 is not a prime, so we will skip this. This is a other case. Next, 7 is a prime number because this is still marked as a uh, in green color. So this is a prime number. So now we will once again 7 into 2, 7 into 3, 7 into 4 till less than number we will do. Okay. So 7 into 2 is 14. 14 is not a prime number. 7 into 3 is 21. 20 is 1 is not a prime number. 7 into 4 is 28. 28 is not a prime number. And then 7 into 5 is coming out of the range. So now same way we are going to do this operation till our number. Okay, there is also one optimization we can do, and you will find what uh, you will find some numbers are still marked in which color, green color, and those value will be treated as a prime number. I think you got the output for range 30. 7 is a prime number, 2 is a prime number, 3 is a prime number, 5 is a prime number, 11, 13, 17, 19, 23, and 29 all are prime number. Okay, so if you will write the answer for this 2, 3, 5, 7, 11, 13, 17, 19, 23, 29 all are prime number. So this is the approach we are going to achieve, and this approach is having some name, and that name I will disclose after writing the pseudocode. Okay, so any problem till now? I don't think so. If you are not getting, you can repeat this video and get what I tried. So in summarized way, if you say we will we will consider all numbers are prime in beginning. Okay, and each case is 1 we will discard, and now we will consider, we will run one loop and check every number. If it is prime number, we will be marking all other number which is divisible by 2 is a not a prime number. Means we will do something and we will mark that, and we will go one step further for next number. Once again, if that number is prime, then we will mark other number which is divisible by that number is not a prime. So what we did for 2, we have marked 4, 6, 8, 10, 12, 14 like that. Same way, if 3 is a prime number, then we will mark 6, 9, 9, 12, 15 all are not a prime number. 4 is not a prime number itself, though then we will skip that case. Then 5 is a prime number because it is marked as a green color yet. Then we will mark all other number which is divisible by 5 is not a prime number. Okay, so let's go. Now I will be writing the pseudocode for this. Before writing the pseudocode, so what we are trying to achieve? We are trying to achieve print all the number which is prime between range 1 to 30. Okay. So for doing this, what I have done, I have taken one array and I am considering all the numbers are prime. Okay. So let's say for this, I need one array, and this array must contain all true value from where 1 to 30. Okay, so if you are taking any array, this should be true. So let's say I am taking one boolean array, boolean, let's say I am taking all prime. Okay, so I need 1 to 30. An array always start with what? 0. And here I need 1 to 30. So I need till 30, that is sure. But array start from what? 0. It means that I need one array of size n plus 1. Means size, if n is 30, then I need 31 length of array If n is 50, then I need 51 length of array. So what I have to create? New boolean and n plus 1 array. And I have to fill this array with true value. By default it will be false, everything will be false. So I have to fill this array with what? True value. Okay, let me write the pseudocode now, then we will talk about other things. Okay, so now what I have to do? Let's say I'm taking void print all prime. Automatically I will be given with number. So first I have what I have to do? I have to take boolean all prime, let's say I'm taking, and then equals to new boolean, it should be n plus 1. So my first task should be I have to fill this array with what? All value true, because I'm considering all value which is available, all is prime. Okay, fill, sorry for that. Okay, fill boolean array with true. Okay, so let me fill it. For I equals to 0, I should be less than, I should be less than what? uh, n plus 1. It should not be less than, so 30 till 30. Okay, less than will work. I plus plus, and now what I have to do? Blindly all prime I equals to true. So this is the first step we have done. Okay, second step, what I have to do? In second step I have to apply the discussed approach. Okay, what was our approach? I have to start with I equals to, now another thing, we talk this, till 0, sorry, till 1 I have to discard actually. So no need to start our loop from what? 0, because array always we start with 0 and we used to go with till n minus 1. Okay, this time I don't need to consider 0 and 1 location, so directly I will go with 2, and I have to go till what? N plus 1, and then I plus plus. Okay, now what I have to check? If all prime of I equals to true, then only I have to go for marking, not prime. Okay, let me take another page. I'll write here for what happened. Okay, so what I'm going to do now, I have to mark till what? Till my number. So I need another loop, and I have to start with where? J. Now another thing you have to see, j equals to, see, if you are at this position, I is in this position, I have to multiply your 2 into 2, 2 into 3, 2 into 4, 2 into 5, like that. Fine. So what we are going to do, if we will write here 2 into I. Okay, I have to start. So 2 into I is what? 2 into 4. It will start from 4, and now I have to go till where? It doesn't look like I. So let me, okay. So j must be less than n plus 1, or you can say j less than equals to n also will be fine, no problem. Okay, then what we have to do now, another thing. So 2 into 2 is 4, 2 into 3 is 6. So if we will increase our loop, because we have to increase the loop, right? So if we can write j equals to whatever the value, j plus j plus I. So first time what will be the value? 2 into I 2, and second time, sorry, 2 into I means 4, 4 plus 2 will be 6, 6 plus 2 will be what? 8, 8 plus 2 equals to 10. It will be matching our criteria. Okay. And what I have to do with that number? I have to blindly go and mark not prime. So we can say all prime of j equals to false. Okay, close the loop and then close the if and then close the for loop. Okay, now, so if this loop is entirely ran, then I will be having all all prime index. If it is index is true, then that number is prime. Okay, likewise we seen in this our example also. If this is true, then this is means that this is a prime number. If this is true, means that prime number. If this is true, means this is a prime number. All this location is called false location. False location is a not a prime number. So what we can do here at last we can go here and write, we can say print all prime numbers. And what we can do, we can write another loop for I equals to 2 and I less than equals to n I plus plus, and we have to check if all prime of I equals to true, meaning that I is prime number. Print I and then close the if, close the your for loop as well. And at last our our program is done. Any problem till now? I don't think so. Any problem, you can repeat this video, you will get the clear idea. Okay, so now we are going to talk about the time complexity. That is mandatory. I'm sorry, what is happening? Okay, just I am marking like where is my, am I skipped anything or not? Those things I'm trying to do. Okay, and at last I function. Okay, all are fine. Okay, so this is the best approach we can say. No, this is not a best approach. We can optimize more also. Okay, so how we can optimize more, we will see now. Okay, where is, so what we can optimize, that we are going to now optimization. What we can optimize here. Okay, so we will write all the things and then we will try to find out. Let's say, right, I am writing I, and I will be writing multiple of I if it is prime number. Okay, so from where we are starting the, we were starting the loop, we were starting from 2, meaning that 2 into 2 is not a prime. 2 into 3, we are striking means, we are making it false. 2 into 4 is not a prime. 2 into 5 no, is not a prime. 2 into 6 is not a prime. 2 into 7 is not a prime. 2 into 8 is not a prime. Likewise, it's so on. Okay, so we have taken what number? We have taken 30. So we can write till 30 also. This is till 16, so it will go on. Okay, now for next 3 is a 3. So with 3, what we are striking? 3 into 2, 3 into 3, 3 into 4, 3 into 5, 3 into 6, 3 into 7, 3 into 8. Likewise for 4, 4 is not a prime number, so we are not going to talk about this. Okay, same way we are going to talk about 5. So 5 is a prime number, so what we are going to do? 5 into 2, 5 into 3, 5 into 4. What we are talking about into is, we are making this number is not a prime actually. Means 4 is not a prime, 6 is not a prime, 8 is not a prime. Same way for 5, means 10 is not a prime. 5 into 3 is not a prime. 5 into 4 means 20 is not a prime. 5 into 5 means 25 is not a prime. 5 into 6 means 30 is not a prime. Same with 5 into 8. Now we will go for 6. 6 we are not going to talk because 6 is already marked as a not a prime. Let's say we are going to talk about 7. So 7 into 2. Okay. So this is it. We are going to talk about till this scenario. Okay, we can continue if you want to optimize more also. Meaning that if you are coming into first, so meaning that 4 is already marked by 2 is not a prime number. 2 into 3 means 6 is marked as a prime, not a prime number. Okay, no problem. Now we will go for 3, meaning that this 3 into 2 is 6 is already marked by 2 is not a prime number. You can see this here, it is already marked, it is not a prime number, and we are marking again, meaning that we are striking again, we are marking it again by 3. 6 is not a prime number. If it is already marked, why to mark it actually? Means that we are repeating the task here. Okay, any problem? So now once again, for 4 we won't go. For 5, 5 means 5 into 2. 5 into 2 meaning that we already marked this 5 into 2. 5 into 2 is already marked by 2 is not a prime number. Okay, same way 5 into 3. 5 into 3 is already marked by 3 into 5 is not a prime number. See here, 3 already marked it is actually. Okay, same way 5 into 4, 20. 2 into 10 will be marking is 20 is not a prime number. This is also marked. This is also marked already, meaning 4. Same way, if we are going to, let's say I'm writing another thing, 7, 7 into 2, 7 into 3, 7 into 4, 7 into 5, 7 into 6, 7 into 8, sorry 7. Okay, same way, if we will observe this, 7 into 2, this 2 is already marked this. See here, 7 into 3, this is already marked here. 7 into 4, this also will be marked by 2 itself. 2 into 14 will be 28. 7 into 4 is also 28. Same way, 7 into 5 means 35, and 35 will be marked by 5. 5 into 7. See, here it is marked already. Same way, this also would have been marked by somebody. 7 into 6 is 42, and 42 would have been marked by 2. Is not a prime number. Okay, you can see here, basically observation is you are marking same number twice or thrice or 5 times also. It is not a prime number. So you can see, if you are starting with 2 and this time if you would have started by 3, and if this you have started from 5, means if I is 2 you have to start with 2, if I is 3 you have to start with 3, if I is 5 you can start with 5, if I is 7 means you can start with 7. So basically I am talking about this loop. I am talking about this part. Okay, instead of this part, if you would have been uh, started this with I itself, I into I, then you would have been done this correctly. Like no, you means you are not doing any kind of repetition at all. Okay, let me copy this if I can copy. So let me write this program once again, and there I will be writing the optimized one. Okay, it will take some somewhat time for you, but no problem. Void print all prime. Here you will have number, and then here I will do some shortcut, boolean, and boolean array, and I'll keep answer new boolean n plus 1. Okay, now for I equals to 0, I less than equals to n I plus plus, and then answer of I equals to true. This is first part. Second part, there we could have done another thing also. For finding finding the prime number, we never, in first scenario only, we have done our loop till n minus till n. Okay, if we would have started this with means we have stopped this loop till square root of n, that also would have been given the answer. Why I am telling that? See here, let's say your n is 50 this time. Okay, so till where you have to go? 7 into 7 means 20, 49, meaning that if you do your iteration till 7, you will be done with your program, done with your output actually. So instead of going till n, we can go till square root of n. So for I equals to 2, already you know why I am going from I equals to 2 and I into I less than equals to n, and I plus plus. This is first optimization we have done. Now we have to check if answer of I equals to true, then we have to start another for j equals to, from where we have to start, I into I. We just discussed that about that. And j less than equals to and n, and j equals to j plus I. This is already we have seen. Okay, we also will find. Fine. And here what we were doing, we were marking not prime, right? So we can say answer of j equals to false. Close this, close if, close for also. We can now, last thing what we have to do, print all prime number. So what we can do, for I equals to 2, I less than n, less than equals to n, I plus plus, and what we can do, sorry for that. Okay, if answer of I equals to true, then only we have to print I, when that is a prime number. Close this and close, enter function. Any problem till here? I don't think so. So we have done with our logic part. We have done with the logic part. So now we are going to calculate about the time complexity. That is a main part. Till now, base time complexity Tc was how much? O of n root n. This was our time complexity for what? Brute force. Okay. So if you see in this, we are not running till n, first thing. So we are always going from 2 and going till n, but our increment is what? I into I always, meaning that if we say I is going to 2 n and j equals to I into I n, 2n means one is j loop and another one is I loop. I is going from 2 to n and j is going I into I to n actually. And this loop is running, I loop is running for 2, and automatically j loop will run n by 2. This you can write n by 2 iteration. Okay, if it is running for 3, then it will run for n by 3 iteration. If it is if for 4, it won't run, because we are already checking, like if it is prime only, then only we will run the j loop. So it will run for 5, so n by 5 iteration. and it is going till root square n. So what will be the j value? J will become n2 and iteration. So this is all something like mathematics thing. So root by, so n to n means automatically how much, what will be the value of I? It will be like, let's say if it is 50, so then it will be something kind 49. So it will be running till n to n. So only one iteration you can say. So it is reducing on n by 2, n by 3, n by 4, and so on. So if you go for generalizing term, we can say Tc equals to n by 2 plus n by 3 plus n by 5 plus n by 7 and so on. Okay, and now if we are going to take n common, we can write 1 by 2, 1 by 3 and 1 by 5 plus 1 by 7 and plus and so on. And this is nothing but sum of all reciprocals of prime number. Now you will ask, like, what is reciprocals and all, and this is a very big term. If you want to understand about reciprocal, you can go and read the articles and all. If you are going for any interview and nobody will be asking what is reciprocals and all. Okay, nobody will ask. And still if you have something kind, you want to study about what is reciprocals and all, then you have to uh, deal with the algebra and all. Like you should know harmonic progression, you should know integration and all, and then you should know differentiation, all these terms. Even I don't know what is reciprocals and all, but if you go with this term sum of all reciprocals, this is nothing but log of log n. Okay, so this is till here, not entire. Okay, so now if you will write about the time complexity, then you can write Tc equals to, n is outside also, so you can say n into log of log n. Okay, and we always write our time complexity in terms of big O, so it will become n into log of log n. Okay, and if you will go another further categorization, this will be approximately 1. Okay, you can read the mathematics and all, and it will be approximately 1. So if you will say about final complexity of this program will become Tc equals to O of I'm sorry for that. No, we cannot say that. I'm sorry clearly. So this is a final actually. So this is your final. So this is your time complexity. And if we are going to talk about space complexity, here also we are not taking any extra. I think we are taking extra space, right? So what we are doing, we are taking one boolean, and that boolean, what is this boolean? It is storing n plus 1 for true value. So what we can say, exactly if you will talk about space complexity, so it will become like O of n plus space. And we always, if you talk about in consideration of big O notation, we always reduce the constant coefficient. So we are going to talk about only the n terms here. So we can say in general term, so generally what we can say, what is the space complexity? Space complexity will be O of n times. So this is our final output. Any problem till now? I don't think so there will be any problem. If you have any problem, you can repeat this video. So last things what I want to discuss, same program I have made in Eclipse, uh, that I will run for you. Okay, so I have made print all prime, and this is a special means specific logic for that. So first part is making all the number as a prime. I'm starting from 0 because I'm not going to consider 0 and 1 index. So directly I have started from 2 and making all the number as a prime, all the location as a prime. And now I am iterating same way. See, I have started from 2 and going till root square and number plus 1. Okay, if it is prime, then only I am going for j loop and making all the multipliers, or you can say dividend as a false because they are not prime. And at last what I am doing, I am printing all the value which is having true, meaning that those are prime number actually. I will attach this also, but I will say by seeing the pseudocode or by seeing the approach spell is itself, you try to write the logic. Okay, and then if you are getting stuck anywhere, then you can follow this. Then only you should follow this code and all. Okay, let me run this. Let's say I'm taking 50. 2, 3, 5, 7, 11, all these are prime number, you can see. Let's say I'm taking another number as a 100. Okay, so you can see all numbers are prime. You go and run the program, you will find this logic is working perfectly fine. Okay, but I will prefer don't look into the program without trying it. If you're getting stuck anywhere, then only you should go and try this logic, try to see the program. Okay, so at last I have given promise, like I will be telling about what is this approach called. This approach is called SE some, I'm forgetting that, Sieve, SEAV, Sieve of Eronotos. Maybe some guy, I don't know. And he even this is also called Sieve prime approach. This is actually, so this guy has given maybe some theorem. So this is a theorem which is used for finding out the prime number. So this is all about today's session. I hope you would have enjoyed this video. If you like this video, please like, subscribe and share, and try, if you want to get the notification as soon as I am uploading the video, please press the black bell icon. Thank you. See you in next video.